Okay, we're looking at this picture. What they're asking us to do is determine what these three triangles have in common. So first of all, let's talk about the three triangles. We have ABE, which is this purple triangle here. That's ABE. Then we have triangle ADE. ADE is this yellow triangle. And then we have triangle CBE, which is this green triangle. First of all, let me go ahead and just trace out the triangle, and let's just look at what they have. So when I trace this triangle out here, and I take it and I rotate it, what do we notice about the bottom triangle? That it fits exactly. So that means that that bottom triangle right here and the top triangle are congruent. Now let's bring it around again. And if you notice, it's not going to fit here, but what if I reflect it? Let's transform. Let's reflect in the Y. Let's see if that will work. And then rotate. Let's see if maybe I need to, there you go, rotate it around, bring it to right here, and we notice that they fit exactly. Okay, so just by the visual and doing that, I know that all three triangles are congruent. Now we have to find a way to do it without using that tool, and that's going to be the math. So when we look at triangle A, B, and E, I'm going to lay out AB equals, then BE equals, and then AE equals. Then I'm going to go to the next one, which is ADE. And I'm going to do the same thing. I'm going to lay out AD equals, DE equals, and then AE equals. And then I'm going to go to the bottom one, to the green one, CBE. And I'm going to lay out CB equals, BE equals, and then CE equals. So what I'm going to try to do here is prove that they're all three congruent by side, side, side. Some of the easy ones are going to be if they're on the straight line. So like BC, that's 1, 2, 3, 4, 5. BC is here, and that is 5. So I'm going to go to AD. AD is 1, 2, 3, 4, 5. AD is 5. And then when I look at the purple triangle, there's not going to be any that I can do that's exactly the same. So now what I have to do is I'm just going to use Pythagorean theorem. So when I look at, not Pythagorean theorem, I'm going to use a distance formula. So when I look at A to B, I'm going to go up 1, 2, 3, 4 over 1, 2, 3. So square root of 4 squared plus 3 squared. So what I've done is I've subtracted the difference from here to here, and I've just cut out several steps. So I did 1, 2, 3, 4, 1, 2, 3. So now I'm going to do this segment here. I'm going to go up 1, 2, and over 1, 2, 3, 4. So I did 2 squared, and then 1, 2, 3, 4 squared. And now I'm going to do that was A to E. So that's 2 squared, and that's 4 squared. Now I'm going to do B to E. So B to E is going to go 1, 2, 1. So square root of 2 squared plus 1 squared. So this is going to be 16 plus 9, which is 25. So I'm going to square root the 25, and that's going to give me my 5. Now I'm going to do 2 to the power 2, which is 4, plus 1, which is square root of 5. And this is going to be 4 plus 16. Again, 2 times 2 is 4, and then 16 and 5, and that's going to give me let's see that again. So 16 plus 4. And that's going to give me square root of 20. So now I'm going to go to DE and I'm going to count 1, 2 over 1. Square root of 2 squared plus 1 squared. And then A to E. I'm going to go up A to E. Well, I've already done A to E on the other one. I can go ahead and do it again, but it's going to be this one right here. They're both A to E, so square root of 2 squared plus 4 squared, square root of 20. So when I look at the blue, I know this is 4 plus 1, which is square root of 5. So when I look here, I have a 5 in common. I have square root of 5 in common and square root of 20. So that I have a 5, square root of 5, and a square root of 20. So now I have those two proven by side, they're congruent. Now I need to go to B to E. So I did B to E here, so I can just redo it again, because it's going to be the same count, 1, 2 over 1, so square root of 2 squared plus 1 squared, and that's going to be square root of 5. And now I need to do C to E. 1, 2, 1, 2, 3, 4. Square root of 2 squared plus square root of, plus the square root of 2 squared plus 4 squared, and that's going to give me square root of 20. So I have 5, square root of 5, and 20. So that gives me all three triangles are congruent by side. That's another way to show that D is my answer.